Recently I was researching ways to de-interleave specific bits that I want out of a UN32, and really any other width of value, but specifically UN32 for my case. It took me a little bit, but I did find a way to do it in the chess engine community of all places. It was really confusing at first until I sat down and tried to figure out what they were conveying, and now that I do know, I'm going to try and teach whoever's watching this. It is made out of a bunch of bitwise ands and multiplies that shuffle the bits to where they should be. And as long as nothing overlaps, or it overlaps in a place that you don't care about, it'll all work out. But this does come with the prerequisite of knowing how binary multiplication works, so I'll start there. Let's start with 13 times 5 in binary. First step you do, you make a column where you copy least significant bit of your B input to most significant bit in this column. So we have 1, 0, 1, 0. Then you take your A input and you shift it over one bit for each copy you make. So we have 1, 0, 1, 1. It's typical to what you do for normal multiplication. And then you add the ones with a 1 in it. So we have 0 here. We don't care about that one, nor that one. All right, we have 1, 0. That's 2. That's 2. That's 2. That's 2. 13 times 5 should be 65. If I'm not stupid and I didn't fuck it up. Now that we know that, we have enough knowledge to actually look at the problem that I'm presenting. I will denote bits that I don't care about as x's. So, let's say we want this to be in the order of A, B, C, D, E, F. This can be done by first ANDing by a mask, so the bits we don't care about go away. They become zeros. Not too hard on that front. But then you multiply it by some really stupid number. We want A to be at the furthest, most significant bit, because that cuts away any garbage over here, and we can just shift it all back later. So A is in its correct spot, actually, and I'll be keeping the rest of the values so we can verify that this won't fuck up our stuff later. There we go. Now we want B over here. 1, 2, 3, 4, 5. We have to shift it over 5 places. I'm actually going to write this as bit shift by 0. There we go. Then you copy the rest of what's there. So now we have A, B, C, D. We need D over, E, and F. Awesome. 1, 2, 3, 10, 11. We shift by 11 places. Now we have underscore D. Then when you add them all up, you have A, B, C, D, E, F. Then you have some garbage over here. As long as the values that we care about don't get any carries from when we're over here, everything works. So we have 0. E plus D. Well, that kind of sucks, because now we have E, D, and this could carry over to be a 1. Then we have 1 here, but then there's no more carries, so we're fine. Nothing carries over. F, E, D, C, B, A. That is the order we want. We can encode this as a multiplication, because if I take 1 and I bit shift it by 2, that's actually doing times 2 times 2. So this is 2 to the power of 2, which just so happens to be 4. We multiply by 4. So we can sum all of these shifts up, and we'll get that multiplier if we put them as powers of 2. If you have bits that shift at the same value, so let's say you calculate one that has 5 as well, you can completely ignore it because it will be part of the window that is shifting. So all we have to do is add up unique values here. So our multiplier would be 2 to the power of 0, which is 1, plus 2 to the power of 5, plus 2 to the power of 11. You multiply by this. After you've ANDed, we have a 16-bit number. We have 6 bits that we care about. we do 16 minus 6. You bit shift it by 10 places. And that gives us A, B, C, D, E, F, our value. Alright, this took way too long to write out as I was explaining it, so I went away and wrote it out. In my case, and in some cases, you need the values to be spaced out even further. What you can do is you can loop the value by putting a 1 every width that your value is, and that will loop it. I don't actually know how to explain that efficiently. But yeah, you put a 1, and that basically pastes a version. So when they all add up, you get a looped version of this. You can use this, which this was my actual case, to do masking on bits that are the same, but further apart. My values were 10 bits long, because I had 5 bits, 0 through 4 for X and Y. And if you try to make this as just one multiply, one add, or whatever, that will not solve. There's not enough spacing in between them. Since we're in a 32-bit register, I had multiplied to loop it by this value. And what that gives me is a copy of each one. If you take the mask of different parts now, there's 1, 2, 3, 4, 5 bits of spacing in my case. These don't have to be in order, as I've shown before, but there are no collisions when you get to here, and no carryovers that occur. And here's that multiplier. It's just this, you multiply it by this, and then at the end, you just shift it away, and you get this.